students, good morning. Today we are going to see about Lagrange's linear partial differential equation. Uh, Partial differential equation if is of the form capital P plus Q equal to R, where PQR, capital PQR are the functions of X, Y, Z, where P is nothing but differentiate partially Z with respect to your X, and similarly Q is nothing but differentiate partially Z with respect to your Y, is called the linear, that is Lagrange's linear partial differential equations, that is PP plus QQ equal to R. Whenever we are having the format like this, it is said to be called as what means Lagrange's linear partial differential equations. We can see how to solve this type of equation. Initially, we have to frame the auxiliary equation, that is dx divided by capital P, dy divided by capital Q, dz divided by capital R. That is, we have to collect the value for capital PQR from our given function, and we have to substitute it in this equation with dx by capital P, dy by capital Q, and dz divided by capital R. And when you are solving this auxiliary equation, two independent solutions will be getting. That is u and v. That we can say it as nothing but what means u of xy is at equal to a, and v of xy is at equal to b, where a and b are nothing but the arbitrary constant. And then the general solution for this one is nothing but pi of u comma v equal to 0, where pi is an arbitrary function. It can also be written in the form of u equal to pi of v or v equal to pi of u. And all these things are all the basic steps. We are having two methods to solve this type of equation. First one is method of grouping. Another one is method of multipliers. So you should know your Lagrange's equation means it should be in the format of PP plus QQ equal to R. So you have to identify the value for P, Q and R, and you have to find it. We have to substitute it in our auxiliary equation. We will be seeing the first model now. That is nothing but method of grouping. First problem is find the general solution of PYZ plus QZX equal to XY. So what's the first step means we have to write what it is given for us. We can identify the given equation. It is on the format of capital PP plus capital QQ equal to R. So for in the first part, without this small p, what is the another term we are having? YZ. That thing we can keep it as what means our capital P. Similarly, in the second term, apart from small q, what are all the things we are having? What are all the variables we are having? That is ZX. That we can keep it as capital Q. And in the right hand side, we are having the value for our capital R, that is nothing but XY. And the subsidiary equations are dx by capital P, dy by capital Q, dz divided by capital R. So this is the subsidiary equation, or nothing but an auxiliary equation. Anything we can say for this one. And we have to substitute this capital P, Q, R here. We will be getting dx by yz and dy by zx and dz by xy. And we can use grouping. Grouping means actually we are having two terms here, 1, 2 and 3. Any two things we can group it. Either first one or second one, second or third, or first or third. Anything we can group it and we can get the value. That is, we can get two types of solutions here. So first we are taking the first two equation, that is dx by yz and dy by zx. If you are taking this first two equation, here in both the denominators, we are having z as common. So we can cancel that z. We'll be getting dx by y, dy by x. And if you are cross multiplying, we'll be getting x dx equal to y dy. And if you are integrating x with respect to our x means you will be getting x. If you are integrating, you will be getting x square by 2. Similarly, y if you are integrating, you will be getting y square by 2 plus some arbitrary constants will be having. So this thing can be written as x square by 2 minus y square by 2 equal to C1. Or commonly, if you are taking LCM and cross multiplication, you will be getting x square minus y square equal to C1. And this is the first equation. This is the first solution we are getting. And if you are taking second and third equation, that is third part, that is these two things we are taking in the subsidiary equation, that is dy by zx equal to dz divided by xy. What's the thing we can cancel it here means we can cancel our x easily. Both the sides we can cancel our x. You will be getting dy by z and dz by y. If you are cross multiplying, you will be getting y dy equal to z dz. So y dy equal to z dz means if you are integrating, you will be getting y. If you are integrating y square by 2, z if you are integrating, you will be getting z square by 2. So similarly, y square by 2 minus z square by 2 equal to c2, or else y square minus z square equal to 2c2. That is if you are cross multiplying. Or 2c2 combined, we can take it as an arbitrary constant small b. So therefore, the general solution can be written in the form of pi of a comma b equal to 0. What's the value for a we are having here means already we got one equation. That is already we got one solution for our a. That is 2c1 equal to a if you are taking means your a value is x square minus y square. Similarly, if you're getting c square, that is b value means you will be getting the value as y square minus z square. So we can write our general solution as like that, pi of x square minus y square and y square minus z square, that is equal to 0. So the given equations were solved and we are getting the solution in terms of pi like this only. So two variable, that is two solutions we are having here. So initially we have to identify, this is nothing but the method of grouping. Grouping means you have to identify what is our value we are getting for capital P, Q and R, and we have to substitute in our subsidiary equation. Any two terms we can take it, combine, integrating, we'll be getting one solution. Another two terms if you are combining, you will be getting another solution. All those things we have to write it in the term of pi of a comma b equal to 0. We will be getting the solution for our PDE. Next, we can see the method of multipliers. That is, instead of grouping means any two terms we can combine it directly. But multipliers means any terms we can multiply both in the numerator and denominator to get our solution. So we will be seeing how we are going to get this one. Here the first problem is nothing but solve x into y square minus z square into p plus y into z square minus x square into q equal to z into x square minus y square. So this thing you can write it in the beginning stage for our solution. We can identify what is the value for our capital P and capital Q and capital R. So the coefficient of small p is nothing but capital P. Coefficient of small q is nothing but capital Q and capital R. So we'll be writing all this P, Q, R. And the general form of the subsidiary equation or auxiliary equation is dx by p, dy by q and dz by r. As usual, what we have seen in the method of grouping, here also we can do it. And then we have to write what is our capital P, Q, R. We have to imagine which term we have to multiply both in the numerator and denominator. In such a way, we have to get that denominator value as 0. So actually, you are having your x and your y and your z here. So if you are multiplying one x in the first term and one y in the second term and y z in the third term means we will be getting a trial or error method. We can try this one and then we can multiply and we will be seeing whether we are getting 0 in the denominator. Either we have get a 0 in the denominator or some term that can be simplified easily. Any one thing we have to bring it here. So directly we can get the 0 if you are multiplying first with the x and second with the y and third with the z. So the term what we are multiplying the denominator, same thing we have to multiply in the numerator. So x dx, y dy, z dz, add up all the numerator and all the denominator terms. If you are multiplying, that is nothing but the each ratio, that is sum of the numerators plus sum of the denominators using the multipliers x, y, z. If you are using the multiplier means that multiplier should be multiplied both in the numerator and also in the denominator. So if you are multiplying means x square y square, here one x square minus x square y square. Similarly, x square z square, x square z square, everything will be cancelled. So you will be getting the denominator value as x0. No problem. The total term here it is not equal to 0 since we are taking each ratio. If you are getting denominator as 0 means you can integrate our numerator part. That is x dx plus y dy plus z dz equal to 0. So if you are integrating the numerator part means you will be getting x value means x square by 2, y means y square by 2, z means z square by 2. So x if you are integrating x square by 2, y square, y means y square by 2, z means z square by 2. And this side, some constant only we are having. That is 0 means we can take it as either C1, C2, A, B, anything we can take it. Since we are having all these denominators as 2, we can take this one also as what means A by 2 or else A. Anything is okay. And commonly if you are cancelling 2 on the both the side means you will be getting x square plus y square equal to A. So this is one solution. One solution you are getting by taking the multiplier as x, y, z. You identify that by the method of grouping, you have to get two solution. Similarly, by the method of multipliers also, you have to get two solution. One solution, we are getting it here. Another solution, we have to find it. We have to imagine which multiplier we can choose it. We can see here, your x, y, z we are having outside means you can take this x, y, z. How can we take this one means if you are dividing by x this term and if you are dividing this term with y, this term with z means you can easily eliminate the remaining term by simple addition. So we can take this one as what means multiplier as what means 1 by x, 1 by y and 1 by z. Clearly you imagine and do it clearly. That is using the multipliers 1 by x, 1 by y, 1 by z. That is we have to different, that is take your 1 by x in the numerator and also in the denominator. Denominator if you are taking it will be cancelled. Numerator it will become dx by x, dy by y, dz divided by z. And this y square minus z square, it will be same as it is. The image is not somewhat clear. Y square minus z square minus x square minus y square. If you are doing in the paper, you will be getting an answer quickly. That is dx by x plus dy by y plus dz by z divided by x square, y square minus z square plus z square minus x square plus x square minus y square. So if you are adding this new denominator term means it will become as 0 and you will be getting dx by x plus dy by y plus dz by z. And you can neglect this 0 and we can say this one as dx by x, dy by y, dz by z. So integration of dx by x is log x, dy by y is log y, dz by z is log z. And this term if you are integrating means you will be getting log b. Any constant we can have it. Since we are having all the term log here, we can say this one as what means log only. So here it is log b. So already we know that in addition log values can be written as like this: log x plus log y plus log z means log of x, y, z. Okay. Similarly, here this term is log b as usual, and both the side we can cancel log. You will be getting x, y, z equal to b. Therefore, the general solution can be written in the form of pi of a comma b equal to 0. Already your a value is x square plus y square plus z square, and your b value is x, y, z. So therefore, pi of x square plus y square plus z square comma x, y, z equal to 0. So this is the solution for our given partial differential equation.